The next rule we're going to look at is for any n bigger than 0, the limit as x approaches infinity of 1 over x to the n is going to be equal to 0. Now why is that? Well, because we have already shown that x to the n as x approaches infinity is going to approach infinity. So if you take 1 and divide by a really big number, you're going to approach 0, so the limit's going to be 0. Let's take a look at the graph. Let's go ahead and put a point on here. This is f of x equals 1 over x squared. So, n is 2 in this case. If we make x approach infinity, we can see that the y value is going to get smaller and smaller and smaller. Now, I can change this graph. Whoops, I moved the point too far up. I can change the n value to, say, a decimal, and we can still see that y is going to approach 0. I can make it odd. It really doesn't matter. My point slid up a little bit too far. Y is still going to approach 0, and that's because I'm taking 1 and dividing by a really big number. Another way to see that, again, is numerically. Let's take, for example, let's just take, I need this to show you. Let's just, again, use the example of 1 over x cubed, and let's take a big number, say 1,000, so that represents positive infinity, even though it really doesn't, but it's more conceptual that way. If we do 1 over 1,000 cubed, we get 1 over a billion. So imagine taking one, let's say a pizza, and dividing it to a billion pieces. Even each piece is going to be practically nothing. And therefore you can see that the limit, let's make sure we go to the right rule here, yeah. Limit as x approaches infinity of 1 over x to the n is going to approach 0. Now the other rule, this has to be an integer. It can't be a fractional exponent. So n can't be a fraction. For all integers n bigger than 0, the limit as x approaches negative infinity, so the same graph we were looking at, of 1 over x to the n will also approach 0. And that's because if you take 1 and let's say you divide by negative a billion, you're still going to be very close to 0. It'll be a negative number, but it'll be like negative 0.00000001 or something. So let's look graphically at that. Let's take this same graph, 1 over x cubed, and let's approach negative infinity. Let's move this over here. We can see the y value is still going to approach 0. Now, why can't n be a decimal? Because then it's undefined whenever n is a decimal at negative infinity. Okay, so let's just do n equals 4, for example, just so you can see it works for even numbers as well. Actually, the point disappeared. Let's do n equals 2. Oh, well, you can still see it if I trace it out. Even if we go to the left, we're still, again, we're dividing, well, in this case, we're dividing by a really big positive number, but it'll still approach 0. So, no matter what, the limit as x approaches negative infinity of 1 over x to the n is equal to 0, provided that n is an integer. And again, numerically, we can see that. Let's just use f of x equals 1 over x cubed. If you plug in negative 1,000, you get negative billion on the bottom, and again, 1 over a negative billion is still really close to 0. It's like negative 0.000001 or something. Alright, so that's it for our two limit laws for this video pertaining to 1 over x to the n at positive infinity and negative infinity. If you have any other questions about this, let me know.